Now we'll start on section 7.3, so plotting decimals on the number line. They should be very familiar with this from fractions. We plotted fractions on the number line, so here it's just a matter of connecting the new decimal notation, noting that the unit is cut into 10 equal pieces, and counting the appropriate units. Okay, so they're usually pretty good at this. Then we have creating benchmarks for plotting decimals. So if you think about it, if you were to plot these numbers on the number line, you probably wouldn't partition the unit into tenths. I know I wouldn't. So what we're going to do here, I think it actually, boop. Okay. We first start by showing them something broken into quarters, and then having them write what these are. So this is 0.25, this is 0.25, 0.75. So connecting 1 quarter, 2 quarters, 3 quarters to the decimal representations. Okay, and then having them get a feel for where tenths, so tenths would be about here, 0.2 would be a little closer to 0.25 than 0.1 would, etc. So 0.3 is a little bit closer, 0.4 is there. Okay, so we don't usually plot decimals exactly. If we're working in the coordinate plane, we're probably just happy, if somebody said 0.65, a little more than a half. Okay, so we want them to get this idea of approximating decimals using quarters so they don't have to write 10 tick marks, especially when they can't write 10 tick marks legibly at least. Okay, so then just giving them something that's not already partitioned into quarters and having them figure out where these values would be approximately. So for 1.6, I'd cut between 1 and 2 in half, and I'd go a little bit to the right. Okay, and you could be more specific if you'd like. Maybe here's 1.75 and show how it's a little closer to that. Okay, so again, basically just getting them familiar with plotting these without putting them on there exactly. Okay. And now ordering decimals. So ordering decimals is notoriously difficult. Okay, and again, it's usually due to their lack of understanding of place value. Okay, but this is pretty general. You've probably done something like this in the past. Have them use the place value chart. Maybe fill in, so for 3.5, fill in the hundredths and the thousandths with zeros, and then compare from left to right. Okay, then we talk about when we have negative numbers, what happens when you have the opposite, and that the ordering changes when you have a negative number compared to the positive numbers. Okay. Then using inequality symbols to make these comparisons. And then rounding. So rounding is even more difficult than ordering. Okay. We try to use lots of different language for this because we use these, if you think about it, sometimes we'll say round to 1 decimal place, round to the tenths place, round to the ones place. And to us, we understand what these all mean, but we want them to know each of them. Lots of times students think that there's a 1/8 place. So if we had 3.6, they forget that this represents the tenths place because here we have 1, tens, hundredths, etc. So they think this is 1/8, tenths, hundredths, etc. Okay, so getting them to remember that this is 1/10, or understand that it's 1/10. Okay, visualizing rounding decimals. Okay, so this is a good example to do in class. If you're at SCC, we got some really cool ink pads with decimal grids, so they could actually use the ink pads to make these impressions on their paper so they don't have to draw them. And then get them to think about rounding to all sorts of different numbers. So we have a decimal, grid way of helping to visualize this, and then we also use number lines. Okay, so here they write the exact number, rounding to the nearest ones place. Well, there's 3, and they have to determine, is this greater than or less than a half? The tens place, you have 3.3. Is this greater than or less than half of the next unit? And it's greater. So since it's greater, they should know that they should round up to 3.4, etc. And then here, using the distance idea, there's lots of questions like this in Math AS2. And this is nice because we have some labelings here, but the intermediate values aren't labeled. So round to the nearest whole number, they'd see 3 is here. They should recognize 2's way over there somewhere. Well, 1 decimal place, it's between 2.9 and 3. It's closer to 2.9. 2 decimal places, they can see that it's closer to this value, which would be 2.91, 2.92. Okay, so again, we will go through the process of having them round using a general, I guess, algorithm process that you probably have shown them, but we really want them to get a picture in their minds of what this looks like, because this is notoriously difficult for them. Okay, so, oh, there it is. Okay, so there's a general method procedure that you can give them, putting these in the place value chart and then using the place value chart to round. Okay, and then we have one last topic, and I think we can include this in this video. Writing and rounding decimals in applications. Okay, so here we want them to see the idea that we don't always round up or round down based on the convention that we used in the past, and that it can depend on the context of a problem. Okay, so Laura runs her own plant business. She computes that she needs to sell 72.38 plants per week to make a profit. She can only sell a whole number of plants. How much does she need to make a profit? So normally they would round this down because 0.38 is less than 0.5. Okay, but since she needs to make a profit, okay, and she can only sell a whole number of plants, they need to recognize that you would round this up to 73. And something that I just said that I want to bring to your attention, I don't know if you noticed. Notice I said 72.38, and that's usually how we say these. We very rarely go into the 72 and 38 hundredths. It can be exhausting and very wordy. Okay? But in eventually, and I tell them this in the videos, we start saying that instead. We use the 0.38, 0.42. Okay, but in the beginning, really try to use the word names so they can connect those word names with what this means. Kind of makes you realize why they don't know that this is 38 hundredths, because we very rarely say it. Okay, and then just a few more examples where they have to round. Oh, I'm sorry, we had one more type of problem. Okay, and they'll do this a lot, possibly in algebra. I know we have this a lot in our intermediate algebra, where we use units of measure that are not ones. So Mount Kilimanjaro is approximately 19.3 thousand feet. Okay, China approximately 1.357 billion. Okay, so this idea of us rounding and using a decimal approximation and a different place value to represent this number. Okay, so this is done in the media a lot. It's done in statistics a lot. A dollar bill is approximately 1.1 hundredths of a centimeter thick. Okay, and this is also connected to scientific notation. We don't formally do scientific notation in number sense too, but this has that general idea, and if they could understand this, scientific notation should be a somewhat quick extension. Okay, so the idea that they're going to go to 19.3, they're going to go to the thousands. Okay, so they'd want 19, 1 10,000, 9 1,000s. The 0.3 really represents 3 hundredths, and fill in the zeros. 1.1 hundredths, well, that would be 1 hundredth, and the 0.1 would represent the thousandths place. Okay, and I believe that is it for this lesson.